So like maybe part A would want the y-intercept. That's pretty easy. So y-intercept. So to find any intercept, you set the other variable equal to 0. That's how I memorize it. So to find the y-intercept, you set x equal to 0. To find the x-intercepts, you set y equal to 0. So to find the y-intercept, you set x equal to 0. So you just plug in 0 for all the x's. So f of 0 is equal to, this will be 0 minus 0. So we'll just get 82 over negative 9. Now I don't know what that is, like off the top of my head. I'm pretty sure that's not a whole number. Yeah, it can't be, because 9 times 9 is 81. So I'm going to go with the decimal, because that'll be helpful for our graphing. So 82 divided by negative 9. I got negative 9.111. You got that too? Okay, excellent. So this is negative 9.11. So as an ordered pair, the y-intercept would be 0, comma, negative 9.11. That would be an easy 2 or 3 points on your test.
In the fraction form or no?
Fraction form is probably better. I did it this way because I'm being weak, and that way it'll help me graph it. So, but yeah, fraction form is probably better.
So when you write it, you have to write it in coordinate?
You don't have to, no. No, I would accept just that.
Okay.
Or just that. A better answer, as Jack said, would probably be this. This is actually much better. Thank you, Jack. I'm feeling guilty. Good, Jack. Good.
Either way, though?
Either way, yeah. You'll probably want to do it this way, John, also, because we're going to have to plot it at some point in the problem. Okay, so that's part A. So, all right, part B. Maybe part B is find the x-intercept. You'll notice in the homework it just says intercept. So on a test, I might ask for both. So B, x-intercept. To find the x-intercept, you set y equal to 0. So y is the entire thing. So we set the entire thing equal to 0. So x squared minus 11x plus 82 over x minus 9. And then we set the top equal to 0. Very good. Yes, whenever you have a fraction equal to 0, you can automatically set the numerator equal to 0. So now we set the top equal to 0. X squared minus 11x plus 82 equal to 0. And this has no real solutions. I know that because the homework is not asking you to find it. It's a pretty cheap way to do it. There's a couple ways to do this. I guess you could use the quadratic formula. That would be a good thing to do, I guess. I really don't want to do it, but let's do it. So A is equal to 1, B is equal to negative 11, and C is equal to 82. You can actually just look at what's called the discriminant, the whole square, the b squared minus 4ac. If that's less than 0, you're going to have imaginary answers. But let's pretend we didn't know that. So x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So x is equal to. So, I mean, maybe I won't ask you for it. I don't know. I haven't made the test. Do you remember this formula from math? Quadratic? Okay, so.
I'm teaching it to my little brother.
Oh, it's so good.
And that stuff, so he came the other day, he was like, you know how to do this? And I was like, yeah.
Oh, it's so good.
Oh. And like all real zeros or something, just doing all that.
Oh, it's so good. Oh, memories. All right, so square this. You get 121 minus 4, and then A is 1, and C is 82. So this is all over 2A, so 2. So this is not going to be a real number because 121 minus 4 times 82, let's see what that's going to be, 11 plus or minus. I'm going to work it out. So 121 minus 4 times 82. I got negative 207. You got that also? Thanks, Ethan. All right, so negative 207 over 2. So no good, no x-intercepts, no. And the reason there's no x-intercepts is because that's an imaginary number, right? So worth going over. I wasn't going to go over it. I was having some doubts, like maybe I shouldn't do it, but it took, what, 3 minutes? So worth it. It's worth it. It's worth it. So no x-intercepts. So that's it. Again, I don't know if I'll ask you for them if they're not there. I might not. I might not. I probably won't. All right. Maybe another question would be, what is the vertical asymptote? That's another good question we can ask. So what is the, right up here, it's a little bit taller. So VA, vertical asymptote. So x equals 9, very good. You just set the bottom equal to 0. And then you get x equals 9. Because the top doesn't factor nicely. It factors only using complex numbers. Yeah?
Is that because it's a negative, it's an imaginary number, that's why there's no x-intercept?
Yes. It's imaginary, that's why there's no x-intercepts. Very good. Yes, good. Yes. Good. It's really important on the test when you write the vertical asymptote to put the x, okay? So vertical asymptotes are always x equals. Horizontal and oblique asymptotes are always y equals. Okay. This has an oblique asymptote, so let's find it. So what is the OA? OA stands for oblique asymptote. Have we done an oblique asymptote in this class before? We have? I don't think so, right? Yeah. So basically, whenever the degrees are the same, or it's bigger on the bottom, you get a horizontal asymptote. But whenever it's exactly one bigger up top, you get what's called an oblique asymptote. So we're going to use long division to find it. Okay, it's probably been a while since you've seen this. So whenever there's like a 2 here and a 1 here, you'll have an oblique. So this is x minus 9. Then I'll do the little symbol. X squared minus 11x plus 80. We're also going to use this to rewrite the function and make the calculus easier, I hope. I usually don't do one from the homework. I usually do the one in my notes because I have the answers, but it's all right, we got this. When you're doing long division, you look at this and you look at this. And the question you ask yourself is, what do you multiply by x in order to get x squared? X. And then I like to use matching. I match it up with the term and I put it there. Everyone does it differently. So again, what do you multiply by x in order to get x squared? X. And then you perform the multiplication. So x times x is x squared. X times negative 9 is negative 9x. So again, the question was, what do we multiply by x in order to get x squared? X. X times x is x squared. X times negative 9 is 9. Then you draw a line. And then I like to put a parentheses and a big giant minus sign. That's what I do. Some people do it differently. You can do it any way you want. You can switch the signs. I don't like switching the signs in class because then you'll go home and be like, did you switch the signs? So you can cancel these when you add them. When you add these, it'll be negative 11 plus 9. So it's going to be negative 2x. So negative 11 plus 9 is negative 2x. What do you do with the 82? Do you remember? Bring it down. I like to use an arrow. So plus 82. I remember when I was in school, I had a teacher who would put an x here. And that was really confusing. Because like, oh, I put an x there to bring it down. I'm like, no! So she would do this. I'm like, what? That's what? So I like to use an arrow. I still remember that. I'm traumatized by that. Then you start the process over again. You ask yourself, what do you multiply by x in order to get negative 2x? Negative 2, very good. So then you put the negative 2 here. Then you repeat the process. Negative 2 times x is negative 2x. Negative 2 times negative 9 is positive 18. Wow, that's cool. Parentheses, big giant minus sign. What's that going to give us?
64.
Oh, never mind. Yeah, you're right. Okay. Oh, how disappointing. Yeah, 82 minus 18 is 64. I was going to do it wrong. Oh, good save. You know what I was going to do? I was going to add them up and get 100. I'm like, oh, 100. Oh, wow. Oh, brain meltdown. Okay, all right. So 82 minus 18 is 64. Thank you. I almost messed up there. I haven't lost any points today, so. Huh? That's why I got so excited. I'm like, oh my God, it's 100? Like, what are the chances? Like, okay. Any questions? Okay, so the OA is y equals x minus 2. That's the oblique asymptote. It's really important to put the y. Okay. I purposely picked this one because you might have one on your test. Yeah.
So the 64, you don't add it and put it over x minus 9?
Yeah, we're going to do that in a minute.
But not for the OA?
Not for the OA. The OA is just this part. Yeah. Yeah, now we're going to rewrite the function using that, Ethan. So let's go ahead and do that. So note, this is going to be beneficial for us in the steps that follow. Our original function can be rewritten in a very convenient way, which we're going to totally exploit and use. It's going to be this piece here. This is called the quotient. So x minus 2 plus this number here. Do you remember what this number is called? The remainder. Yeah, and the one that people never remember is this one here. Do you remember what this is called? No one ever knows. It's the divisor. Yeah. So it's the quotient plus the remainder over the divisor. If you're wondering how I know that, like, oh, because he's a teacher. Yeah, but this process is called the division algorithm, this process. And these are polynomials. In mathematics, there are other division algorithms that you study if you study math. I just got goosebumps. There's all kinds of division algorithms you study. And so you really end up learning what they're called. So then when you do this in the calculus class, you're like, oh yeah. Quotient plus remainder over divisor, duh, because you've seen it so much in other classes. So that's why I know it, if you're curious.
Make like a reverse here instead of doing all that.
Yes. This is going to make it easier to work with. We're going to use this now when we take the derivative instead of working with all this. It's going to make our life much easier. Piece of cake. Also, you can kind of see why this is the OA. When x approaches infinity, this piece here approaches 0, and your function approaches x minus 2. So it's called an oblique asymptote. If you're wondering, if there was a 3 here, you would get a quadratic asymptote. I Googled it once, though, and it wasn't very popular. I found like some research paper, and they barely talked about it. And so, but it's a thing. It's a thing. So
if we would never get a 3.
No. If you had a 3 here, you'd probably have a 2 here. Yeah, it's rigged. Even though it's calculus, it's still. That's really useful. You can also write it like this, because we have to differentiate it, right? So it might be good to write it like this. This is just for our benefit. But you don't want to use the quotient rule here because there's a number there, so you can bring it up and just take the derivative. That'll make it easier when we differentiate. Beautiful problem. I'm going to do this just to add clarity. I like it's like a puzzle. It's like Legos. I don't even like Legos. They're too hard. Okay. So let's find the derivative. So E. Let's find the derivative. Fill in the blank. Let's just work it out. So I guess we can take the derivative here. So the derivative of x is 1. So this is 1. I feel like I've accomplished something. The derivative of negative 2 is 0. So that's gone. This derivative here, you put the negative in the front. Yeah, so you get negative 64, parentheses, x minus 9. Then you subtract 1, right? So it's minus 2. And then technically it's times what? Times 1. I'll write it, but then I'll erase it. Is it okay if I erase it now? I'm going to erase it. I feel really bad. I don't like erasing. I won't. I'll write it again. Oh. So this is going to be, I'm going to write it like this. 64 over x minus 9 squared. I'm going to leave it like this for now. That's the first derivative. So usually I'll ask you to do that. I know in the homework it doesn't ask for that, but I'll guide you through. The homework will probably just ask for like the maximums, minimums. I'll guide you through it a little bit more. So you'll get points for your work in a sense. Let's find the second derivative. I'll call that part F. So find the second derivative. If you're wondering why I wrote it this way, it's because later on we're going to use this for something. But when we're taking the second derivative, we probably want to use this piece here. It's more beneficial. The derivative of 1 is 0. This worked out really nice. We didn't have to deal with this beast. So it'll be negative 2 times negative 64, so 128. Yep, 128. And then this will be parentheses, x minus 9 to the negative 3 times the derivative of the inside, which is 1. Okay, and I'm going to go ahead and rewrite it again. F double prime of x equals 128 over x minus 9 cubed. That would be the second derivative. It's kind of nice. For some reason, it feels really easy. I don't know. I don't know. It feels easier. I expected worse. I was expecting it to be 5. I know, there used to be 10. Some of them have square roots, and like, yeah, it's ridiculous. It's yeah. Oh, yeah. G. Let's find the relative max and min, if there's any. If there's any. So to find the relative maximums and mins, we can do it a couple ways. Let's do it using the first derivative. You can take the first derivative, set it equal to 0, find the critical numbers, and then you have two choices. You can draw a diagram and find out where it's increasing, decreasing, or you can plug them into the second derivative and use the second derivative test. I guess we'll figure it out. For now, let's focus on finding the critical numbers. So you take this and you set it equal to 0. And I'm writing kind of small, trying to fit it all on the board. So I guess we can add this over to the other side. That would be a good idea. Maybe take this and add it. So we get 1 equals 64 over x minus 9 squared. Oh, this is not so bad. I see how to do it now, I think. Multiply by x minus 9 squared. I see, said the blind man. So we're here. How do we get rid of the 2? What's the next step? What do you do to both sides? Square root. This is why I got excited. Because the square root of 64 is what? 8. See, we got a nice number. It's not like it's not like a 67. Like, oh, calculator time. Plus or minus. Very good. Plus or minus. You do that because you have a variable here. So when you have a variable and you take a square root of something squared, that's when you have to put the plus or minus. When you're solving an equation. So keep that in mind. So if you have x squared equals 64, when you take the square root, you have to put a plus or minus because there's 2 solutions to this equation. But if someone says, hey, what's the square root of 64? And they write this symbol, they usually mean what's the positive square root? Because it does have 2 square roots, but they want the positive one with that symbol. So just random knowledge, yep.
So x would be undefined at 9, but it wouldn't be a critical number because it's undefined in the original.
Yes, thank you. Very good, very good. Yeah. So when I got here, I should have said something and I didn't. You're supposed to look to see where the derivative is undefined. I looked at it, I thought about it, and then I just did it in my head, didn't say anything. But yeah, 9 is a possible critical number because the derivative is undefined there. But he's right. You can't plug it into the original because 9 is a VA. So good, good, yes.
If we did a sign diagram, would we still plot it in the...
You still plot the 9. And in fact, we will. I think we should. Yes.
What
So
about if you're using the second derivative?
then you wouldn't. In theory, the sign diagram is the better way to do it because if you didn't have a calculator and you're doing this all by hand, you would want to know where it's increasing and decreasing. So a sign diagram would be more beneficial than the second derivative test. Boom. It's going to give us 17 and 1. These are going to be our critical numbers. These are our CNs. 9 plus 8 is 17. 9 minus 8 is 1. All right. So now let's do that sign diagram. So we'll draw it like this. So here's, we'll also have to plot 9, right? So 1, 9, thank you, 17. Good, I'm glad you mentioned that. You have to plot the vertical asymptote because 9's a VA. And we're going to see where it's increasing, decreasing. We're doing it the old school way, the way we did it before this test, like the second test. So we're going to plug in numbers to the first derivative. So this is a sign diagram. Let me write it down. Sign diagram for f prime. For f prime. So how about 0? That's an easy number we can plug in. That's a nice one. We can pick it from here. So let's do it. F prime of 0. So that'll be 1 minus, just plug in 0 here. That's going to be positive on the bottom. So 64 over 81. That's greater than 0. Because you're taking 1 and you're subtracting a number smaller than 1. 64 over 81 is less than 81 over 81, which is 1. So it's like 1 minus, I don't know, something smaller than 1. So this is still positive. So would it be increasing or decreasing here? Increasing, so I'll put the arrow. So it's good review. It's good review. I guess, how about 2? 2 is a nice number we can plug in. Let's do 2. So f prime of 2 would be 1 minus 64. And I'm going to skip a step here. 2 minus 9 is negative 7. Negative 7 squared is 49. This is going to be less than 0 because this number is bigger than 1. You have 1 minus a number bigger than 1, so it's less than 0. You can put it in your calculator as well. 49 over 49 is 1. 64 over 49 is a number bigger than 1. You have 1 and you're taking away something bigger than 1, so it's going to be negative. Old school way of doing it, like no calculator, so that's decreasing. Used to be a teacher, he's retired now, he's in his 70s I think, and he would always go on about how important this was. Like, oh yeah, the size of numbers. That's how he talked, he was really cool. Because back in his day, I guess they didn't have calculators when he was a student. Like, they did everything by hand. They had books, and they had tables of logarithms, and you had to learn how to use the book to compute the values of logs, like old school, like wow. A nice number, I know, it sounds really hard. What's a nice number between 9 and 17? Yeah, 10. I'm so glad you said 10. Like, I was like, 11. No, 10. It's 10. I don't know why I asked. I don't want to use that. If you said 11, but like, let's use 10. No. 1 minus 64. 10 minus 9 is 1, so we get 1 squared, which is just 1. Oh, isn't that definitely negative? Yeah. Yeah, super negative, so that's decreasing as well. And last but not least, how about 20, or I don't know, 20? Can we do 20, I guess? Or, yeah. Why not? Okay, I don't know. This is 1 minus 64. 20 minus 9 is 11, so 11 squared is 121. All right, 20 minus 9 is 11. 11 squared is 121. So you have 1 minus a number smaller than, so it's going to be greater than 0. Thanks. I'm zoning out. So that's increasing. Long problem. Okay, so now we can find the maxes and mins. We know it's increasing, decreasing, decreasing, increasing. Here we're going to have a max. What are we going to have here? A min. Yeah, because these are critical numbers. So let's go ahead and find the mins and maxes. To find them, where do we plug in the 1 and the 17? The original function, yeah. So for the max, that's going to be from the 1. So f of 1, going back to the OG func, would be 1 minus 11 plus 82 over 1 minus, oh, you know what? We don't have to plug it into this one. We can plug it into this one too, can't we? Do you want to use this one instead? It might be easier. Yeah, let's use this one, sorry. So 1 minus, you can use that one too, but 1 minus 2 plus 64 over 1 minus 9. So that's going to be negative 1. Oh, look, 64 over negative 8. Oh, it's so good, because we can do it by hand. Old school. Negative 1 minus 8 is negative 9. That's pretty nice, totally nice. I did not expect, I haven't done this problem. It's from the homework, so I was expecting like at the beginning of the problem, we got this, and I'm like, oh no, like that's it. Like it's all downhill from here. Like this is gonna be nasty, because I know the one in my notes has nice numbers. So that's the max. You can write it as an ordered pair. As an ordered pair, the max would occur here. That's where the maximum occurs. That's what the homework wants. It wants the ordered pair. Kind of fun. Let's do 17. F of 17. I'm going to go back in here, I guess. So I'm going to skip some steps this time. 17 minus 2 is 15. So 15, I'll write it. 17 minus 2, feel guilty, plus 64 over 17 minus 9. That's going to be 15 plus 64 over 8. 15 plus 8 is 23. Whoo! 17 comma 23. And that's the, yeah, so this is where the max occurs. The max is here. And the min is here. Let me pause here and let you catch up. This is a lot. This is one problem. So yes.
The oblique asymptote is the same as the slant asymptote.
Yes, thank you, Sarah. Good. Sarah had a really good comment. Thank you, Sarah. The oblique asymptote is also called a slant asymptote. Yeah. Mm-hmm.
So if you have y is 23, positive 23.
Uh-huh. Yeah.
And then y is negative 9.
Uh-huh. It's bothering you, right? Because you say the max is smaller than the min?
Yeah.
Is that bothering you? Yeah, check it out. So say you have a min up here, and you have a max down here. The min is bigger than the max, right? Because it's relative. Yeah, you might have VA or something. You see it? Yeah, I know. I think it was Logan asked about that once. Maybe it wasn't. Yeah, I think it was. It was a good question. I was over here. I remember, and you asked about it. I remember you asked. I was like, oh, it's a good question. Because look, so this is a min, but it's bigger than the max. So that can happen. That's a good question. It's thinking. It's good. Good. This is good stuff. This is calculus. Whoo! A, B, C, D, E, F, G, H. H for hard. No, I'm kidding. Let's find the inflection point. So inflection points, if any. IPs? I don't know if there's any because I haven't looked at my notes. I don't think there are. I'm pretty sure there's no IP. We're almost done after this. So to find the inflection point, we take the second derivative and we set it equal to 0. So it's going to be so when you do that, you set the top equal to 0. Then, no, that's it. This doesn't make any sense. No, this is just not right. So it doesn't make any sense. So what do? So you plot all points of interest. So the only point of interest in this case that we could plot would be, well, what do you think we should plot when we're looking for IPs?
But don't we need to find where it's undefined too?
Yeah, so 9. So there's not going to be any IPs because even if the concavity changes here, 9 is a vertical asymptote. So we'll never have an IP. But since we're graphing this, it might be beneficial to find out where it's concave up and concave down. So let's go ahead and do that as well. So there's no IPs because 9's a VA. And that's the only possible place the concavity can change because the second derivative was never 0. But let's check anyways. How about 0? Let's plug in 0. So that'd be 128 over negative 9 cubed. Well, when you cube a negative 1, a negative number, it's negative. So that's negative. So would it be concave up or would it be concave down here? Down, yeah. So let's do that. Good stuff. How about 10? Let's do 10 now. That's a nice number. F double prime of 10. It's going to be concave up. Because 10 minus 9 is 1, so it's 1 cubed, so it's concave up. Very good. But it's not an inflection point because 9 is a vertical asymptote. That happens in 3.4 on some of the questions. That section is, again, don't feel bad if you're having a hard time with that section. You can email me and I can give you answers if you want. It's tough. Like it's not uncommon for like it's the week before the test and like you haven't finished 3.4. Like that's normal. Like people will get behind. It's really tough. Okay. That's a bad idea if it happens. You don't want that to happen. So, but. It's really bad. Let's do the graph. So A, B, C, D, E, F, G, H, I. Pirates say I. So we have, no, they say R. Pirates say R. So this is the x-axis. Yeah, pirates are bad, right? Pirates kill people, I think. Yeah. I mean, they're fun. We talk about them. There's like Disney movies and stuff. But you know, I think walking the plank was real. All right. What can we even plot? I guess we have the intercepts, yeah, we have that. So 0, that's like down here. So if this is negative 9, then that's going to be like right there. That's the y-intercept. It's a little bit smaller than negative 9, right? We don't have any x-intercepts, huh? We have a VA, don't we? X equals 9. So I'll put that here. So this is 9. One time I did that in class, and then someone did it back. Yeah, and from the other class. It was in a different building. Yeah, and then I saw the guy in the bathroom. It was really weird. He's like, hey, were you in S204? I'm like, yeah. I was like, oh, yeah, it was me. I'm like, oh, okay. Like, oh, it was really weird. Yeah. So that's 9. And then x minus 2. So I don't know if you know this, but y equals x looks like this. This is y equals x. So x minus 2, you just bring it down to. So this will be negative 1, 2, 1, 2. It's beautiful. Right? It's fun. This is the only time we get to do it, right? So might as well enjoy it. So that's y equals x minus 2. Notice that it's perfect. I mean, kind of, not really. But those points are correct. If you plug in 2, you get 0. Plug in 2, you get 0. Plug in 0, you get negative 2. Yep.
On the graph on the test, you want the asymptotes.
Yeah, the asymptotes, the intercepts, and just rough labels. Doesn't have to be perfect. You know, just decent. So what else do we have? We know that it has a max at 1, negative 9. So that's going to be here. So it's going to do this. Oh, wait a minute. No, it's not right. What's this dot here?
That's the.
Yeah, so it's going to do. That's the intercepts. It's going to do this. It's tough. Right there. See, that's 1. that's -9. So this is 1, -9, and that's the max. That was really hard to draw. Whew, getting near the end of class, almost messed up. So that's -9, so that's 1, -9. You see, here's the y-intercept, then here's 1, -9. So really sneaky, you see it? And then 1723, wow, that's like the time or something, but not really. That's like way, I'm not going to draw it to scale because it's ridiculous. So really bad graph here. But let's just say 17 is here and 23 is here. So it would be here and it would look something like that, not drawn to scale. Notice it agrees with the concavity, concave down from 0 to 9, concave up from 9 to infinity. By the way, there's nothing here. Because if there was, it would fail the vertical line test and it wouldn't be a function. So you have nothing here. There's nothing here. And you have these other things that you can use during a test. They're called calculators, right? So you can put it in your calculator and hit graph, and you got it. So that's probably what you should do, for sure. But that's how you would do it without a calculator. That's how they used to do it, you know, I guess, back in the day. So we fit it on one board. Pretty amazing. Any questions on this stuff? Anyone like this? No. Yeah, I actually like it more now. I was really dreading it, and now I'm like, I don't know. I'm feeling it. I like this problem. I don't know. I think I'm happy that we fit it on one board. Like, it just looks better. It's like, it's there. It's all in little boxes everywhere, you know. It's great.